To conclude, we have derived the very important first parameter, which is called frequency deviation, and it comes out to be mu f into fm in case of an fm signal. This is obviously the case when modulating signal is single frequency sinusoidal signal. So delta f, which is the maximum departure of the instantaneous frequency from the carrier frequency on both the sides, the upper side as well as on the lower side, is measured in hertz, and it is given by mu f into fm. So you can see that if you are using maximum departure of the instantaneous frequency, then the value of mu f, the modulation index, will also be very large. So what is the significance of mu f and frequency deviation? Modulation index mu f simply represents the depth of the modulation. It represents how far you are taking the instantaneous frequency from the carrier frequency. For a given modulating signal, fm will be constant, and hence for large values of mu f, it simply means that the value of delta f, which is a frequency deviation, is also very large. In other words, instantaneous frequency is taken far away from the carrier frequency. So if delta f is large, that means mu f is large, and that means the depth of modulation is also very large. In such a case, it simply means that the modulation is done with much more quality, and the effect of noise on the signal transmission and the reception of the signal on the receiver side will be very less. On the other side, if the values of modulation index are very low, that means we are using very small frequency deviation, and in such a case the depth of modulation is small, and hence the quality of frequency modulation will be less. In such a case, there will be good chances that the noise affects the transmission of the signal, and the quality of the reproduced signal on the receiver side may not be as good as what it would be in the previous case. Please remember that this final expression that we have derived are only valid when input modulating signal is of single frequency. If this is not the case, then you have to start from the general expression of fm and derive the actual expression of delta f. The frequency deviation definition will always remain same. You have to somehow get f minus fc first, and you can get f by differentiating the angle part of the modulated signal, and then simply find out the maximum value. So I repeat, if the modulating signal is not sinusoidal and any other signal in nature, then you have to use the definition and find out the expression of delta f. If it is single frequency sinusoidal signal, then delta f will always be equal to mu f, which is the modulation index, multiplied by the frequency of the modulating signal.